So this is the next episode of my experimenting with streams and concurrent parallel kind of asynchronous programming with Flutter. And this time for the Flutter pagination tutorial I created a new branch, and then this is the streams with Future Builder. In the previous version, I don't want to spend on that much time. It seemed to me that stream builders directly with the list view items do not work properly, so I decided to give a try to a version where the list view items are built with Future Builder. So this is where I was experimenting with a stream builder, and it seemed to me that it really wasn't okay. Sometimes it worked, but then it was absolutely not reliable. Future Builder is brilliant. So this was also my very first experience. The Future Builder for list view items are excellent. So therefore, with this combination, I used streams heavily in the block, which provides data for the Future Builder. So that branch is about this solution. Let's check out how it works. Let me just restart the project. Here you go. It worked excellently. And as usual, behind the scene, the data are retrieved from the server like crazy. The performance is astounding, so no problem with that. Yes, even with this solution, I kept my original idea that all the pages which I have already loaded are kept in memory. So, after this experiment, let's check out how this was implemented. First, the user interface. Again, as I explained in introduction, that this is a list view where again I'm using the Future Builder. However, this time I created a new function called fetch photo async. Of course, because this is a Future Builder, this fetch photo async returns a future, and then the rest is practically the same. So nothing special, nothing new here. The real stuff is how this block was implemented this time. So we have here, as I mentioned, my fetch photo async function, which returns a future, and the key components of this solution are a photo requests stream of integers, and then this fetch photo async actually it creates a photo request if it's not initialized, and then starts a photo request processor. I will explain that later. Then it creates a future just on the fly, and then gives it an asynchronous job of add the photo request to this add the index, this integer, into this photo request stream. The reason I made it with a future just for fun. I haven't tried if it works possibly it works fine without the reason I suggest and recommend and I love using futures in this highly concurrent situation that this gives the Dart loop, event looper machinery to schedule the chunks of elementary jobs easier. So possibly this practice of mine would be completely fine. And then comes the heart of the solution, because this fetch photo async should return a future to the future builder of the list view builder. And then I've implemented a couple of solutions, actually basically two solutions. And then for this explanation, I use here, explain here a one-liner. The idea that the other pillar of the solution is the photo responses. The photo responses is another stream which returns photo responses. The photo response is a simple helper class with an index. This is what comes from the request, the photo request, and then the other one is the photo object itself. So in the photo responses, this fetch photo async function, this future, expects the response in the stream, and then here I use a first where stream function which figures out which element matches the index. The PR is a photo response from the stream, and then this is awaiting here. So this returns actually the photo only when the data are provided. So the future builder is waiting nicely until the stream finds the response. Who is responsible for providing the data into this queue? This is, excuse me, the photo request processor. The photo request processor's main job is first initialize the photo request processor function. The solution is that we have only one photo request processor at a time. We don't need more, only one is enough. And then when it is empty, the start photo request processor simply creates a future with an quite nifty async anonymous function. Of course, this could have been factored out into an independent function, but for this solution this is completely fine, because anyway we have a representation on the class level. So when you want to see where is this photo request processor async, this is the function actually. So therefore I think this is quite fine. First it initializes if the photo responses stream is not created, it creates immediately a broadcast stream. This is important to be a broadcast stream because of a number of technical reasons. I don't want to go into the detail. The photo requests in this solution can be just a regular stream, but the photo responses is better to be a broadcast stream. So when it is creates, then yes, I love this stream iterator. It's really fun to use. It just used here to get the data from the photo requests, returns an integer value, and here I can use simply a while function. The reason I can use this while, and this is an infinite loop, and then it is not blocking the whole system. Why it doesn't block? Because every time, every iteration has a number of small chunks of codes which are futures or the library functions. So therefore the non-preemptive nature of threading, process handling of Dart can, with this event loop machinery, could work perfectly fine. So that's why this infinite endless while loop doesn't make any problem. And later in my explanation I will show you a tricky way how this loop, how this future is cancelled actually when it is not needed anymore. So when you are working with this screen, definitely this looping machinery should be in place, otherwise it won't work. Of course, when the data have already been loaded, as seen here, it is not, but when we just move back after the this, okay, you see it starts working right away and fetching more and more data. So this processor is brilliantly fast, as you have seen here. It is definitely not blocking the system, and what it does, we have this move next, and then the current from this is the index what we want to serve, and here I create another future. So within a future, this whole processor is a future, so this is an asynchronous function. I also create an asynchronous function to load the data and also load photos. This is again an asynchronous function, and then again another asynchronous function. So when so if the photos is empty, if this is a list, so this is the fourth pillar of this. So we have the API, so five pillars: API, the processor, the request queue, the response queue, and the list of the photos in memory as a kind of cache. So instead of coming back again and again to the database, so these photos is a list of photos is kept in memory. And then it returns a photo response when it finds for the index. And then for the sake of fun, I also created here a then operation where this photo response, so this is a typical scenario, the first in a sequence of future, the initial function, and then these can be chained together. So this is the value from the previous function's return value. So this photo response, then if it's not null, we just add this to the photo response queue. This is the photo responses, which is actually being monitored by the every and each of these small future function, listener function, which are created for every and each of these future builder. So you may wonder that are we creating 400s of, actually they are not created. So because then maximum 13 of these objects are kept in memory. My experience with this architecture. So the list view is so smart. So this list view is absolutely brilliantly implemented, this list view either. So this is the item builder. So when this is in my example just how to say called only 13 times initially, or 14 times, and then only requests more and more data when the user really starts paging. At the same time, it starts dropping the data from dropping the pages, and then when the user scrolls up back to the beginning of the pages, therefore it again requests data for the first pages. So it's implemented absolutely brilliantly. So therefore this whole performance is really optimized, so you shouldn't worry about that. Anyway, so this is a finicky solution, but quite straightforward. So it's quite regular. The concept is the pattern is very similar to what I'd call the producer and consumer pattern, which is typical in database system, service broker systems, which I worked quite a lot in previous years. So anyhow, so this is the heart of this whole architecture. And then what else? But actually that's all. Then one more thing, let me just show you, because we are working with streams. And then I implemented here a dispose function, which is expected to be invoked and called whenever it is not needed. In Flutter, the dispose function, in Dart, there is no way for a destructor, unlike other languages. So, and as far as I know, only the stateful widgets, the state class of stateful widgets has a dispose functionality. So that could be one of the place where you can implement your dispose. So therefore, I definitely recommend to create at least your main page to be a stateful, just because being able to call the dispose function. Anyway, so here then the big question, so just closing the photo, the queues are straightforward. The interesting question, how can we kill a future? Because our photo request processor async runs when it is instantiated, then it runs forever, and then in the future function doesn't have any function. The future object doesn't have any function, something like cancel or break or whatever. However, it has the timeout function, and then here I just simply define a timeout, and immediately when it is designed, I just define 1 milliseconds. That is, whenever I create this, it's within 1 millisecond this processor stops working. And then, because I also created an empty on timeout, I don't have to care with the try catch, because if you don't define the on timeout, you have to sandwich this call between a try and a catch, since a timeout exception is thrown. But with this on timeout, this is not necessary. And then this photo request processor is practically killed, and then that's one of the way, and it works excellently. This is a very nice example, and I was wondering how how Dart can do that, because it doesn't have preemptive multi-threading. But I think Dart is using not only one thread but multiple threads. So therefore I can imagine that maybe one of the thread is something about timeouts and timers, which simply sends messages over to the event loop that, hey guys, timeout is over and please try to kill this process, which is absolutely possible since I have explained this, the implementation. Let me just show you again. For example, come back here. The while loop, the heart of the while loop is actually move next, waiting, practically waiting. I think this is a perfect moment when the event loop can simply kill this photo request processor. So nothing really a big magic here. And then another fancy thing, how can I kill this processor? Because I have here only a stateless widget. I didn't want to change this my application into a stateful widget just to have the possibility to demonstrate, to call the possibility of the destructor. So therefore there is one tricky thing I can show you, that this is what I've done here just for testing. I created here right away when the application start a future. I started the future with 5 seconds, and then I close the block dispose. And let's check out how it works. Let me just restart the application. Restarted, data loaded, and then after 5 seconds it was killed. Now comes the tricky thing. When I start scrolling, it works great. How is that possible? Actually, that's behind the defensive way I program this application. So whenever the user starts again scrolling this screen, then the fetch photo async starts being called by the list view builder again. And then upon the very first fetch photo async call, it checks photo request. Oh, I don't have a stream. It creates a stream on the fly. And then it goes into the start photo request processor. Start photo request processor. It starts. Oh, the photo request processor is null. Oh, let's create then a function and then starts it immediately. And then the photo processor immediately, first thing, oh, photo responses, oh, it's null. Let's create then a stream controller. So that's the way actually the system can be killed, destroyed, destructed, but it can be revived any time. So this is what I'd call a defensive style of programming. So I hope you love this, whoever is watching this video. So I'm not making my videos for the big public. If there are some people who has the chance to find these videos, because there are so many fantastic tutorial videos, most of them are for beginners. This is really hard stuff which I'm doing here, but anyhow, I think this is a kind of masterpiece of using futures, list views, infinite looping, paging, and asynchronous functionality, and so on and so forth.